In this video, we're going to learn how to solve trigonometric equations, linear and quadratic. Let's start with the following equation. Cosine theta is equal to square root of 3 over 2. Theta in this case is the angle, and we want to determine the measure of the angle whose ratio of cosine is equal to positive square root of 3 over 2. The angle that we're looking for has to be on the interval between 0 and 360. And there are possibilities of multiple angles. There could be one, there could be more than one. Let's see how that happens. So in order for us to solve this equation to get theta, we need to determine the inverse cosine of square root of 3 over 2. Theta is equal to cosine inverse of square root of 3 over 2. The ratio is given to us as exact ratio, which could mean that this is one of the special angles that we're looking for. So let's think of which angle will produce the ratio of square root of 3 over 2 for cosine within one of the special triangles. Since I don't have a 1, I will assume that this is one of the triangles that's combining the 60, 30, and 90 degrees. So there is a 1 here, there is a square root of 3 here, and there is a 2 for the hypotenuse. Cosine of the angle is equal to square root of 3 over 2. Cosine is adjacent over hypotenuse. Square root of 3 over 2. Square root of 3 is adjacent to the angle of 30 degrees. Excellent, and it's positive. So now let's look at the quadrants. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4 of the unit circle. On the unit circle, we use the cost rule to determine the sign of the ratio. C, A, S, and T. Cosine is positive in the first quadrant and in the fourth quadrant. And we have a positive ratio here. So we need to look for an angle in the first quadrant, which is an acute angle. Therefore, we can say that one of these solutions will be our 30-degree angle. Another solution is possible, and it will be an angle in the fourth quadrant, from 0 all the way to here. And the angle here that we're not quite making to complete rotation is also 30 degrees. This is our related acute angle that we also have here that we've already indicated is one of our solutions. So what is the principal angle? What is that angle in the fourth quadrant that also is another solution to our equation? We can determine it by doing 360 subtract the related acute angle, and that gives us 330 degrees. So we have two solutions within one rotation between 0 and 360, and those solutions are 30 degrees and 330 degrees. We're not considering angles in quadrant 2 and in quadrant 3, because in those quadrants, the cosine ratio will be negative. And in our case, the cosine ratio, square root of 3 over 2, is positive. Let's look at another equation. Here, we're given an equation, -6 sine theta equals 3 square root of 3. Before we can solve for theta or isolate for it, we need to remove everything that prevents us from isolating theta. So first, let's divide by -6 on each side of the equation. This will help us reduce it here, and we end up with sine theta. Then here, 3 and -6 can be reduced, and this will give us 1 and 2. Therefore, we end up with the ratio of square root of 3 over 2 with a negative, and sine theta is equal to that value. Again, we have an exact value of the sine ratio. So theta will equal sine inverse of negative square root of 3 over 2. Since we're given the exact ratio, we can try to use one of the special triangles in order to determine the angle that could be theta. Let's see. Since I have square root of 3, it means that I am dealing with the 60, 30, 90 triangle. This is 1, this is square root of 3, and this is 2. So square root of 3 over 2, and it's a sine ratio, opposite over hypotenuse. So the angle that I'm looking at is 60 degrees. 60 degrees will not be one of our solutions. Why? Here is why. According to the CAST rule, C-A-S-T, the sine ratio is negative in quadrant 3 and in quadrant 4. It is positive in quadrant 1 and in quadrant 2. The ratio that we have here is negative, and the angles of 60 degrees is located in quadrant 1. So this will be our related acute angle that we will use to find the solutions to this equation, but this angle will not be one of our solutions. So then I will just translate this angle to this quadrant and to this quadrant. And then here I have a complete rotation of 360, and here I have half of a rotation. In order to determine my first solution, I need to see how big this angle here is, the principal angle from 0 to 60 degrees over 180. So theta 1 will be half of a rotation plus another 60-degree angle, and that gives me 240 degrees. Another angle that I'm looking for is in the fourth quadrant. Again, a complete rotation is 360 degrees, but I'm not quite making to a complete rotation. And the angle that I'm not quite making it by is 60 degrees. So theta 2 is equal to 360 subtract 60, which is 300. Therefore, you have two solutions here, 240 degrees and 300 degrees. They will produce the negative ratio of sine that is equal to square root of 3 over 2 with a negative sign. The 60-degree angle is not one of the solutions. However, it is the related acute angle that both of your solutions are based on. This equation is a quadratic trigonometric equation. We need to treat it as a quadratic equation, solve it as a quadratic equation by factoring or using the quadratic formula, and then continue solving each one of the linear outcomes as two separate or one or two separate trig equations. Let's see how. Let then theta be x. So then we will end up with the equation 3x squared minus 5x minus 2 equals 0. we have a quadratic equation that we can try to solve by factoring. We need to multiply 3 by -2 to see which two numbers produce a product of -6 and the sum of -5. -6 and +1. Decompose the middle term. And then group them. So 3x squared and -6x can be grouped together. X minus 2 can be grouped together. Then here we have 3x as a common factor, x minus 2 plus x minus 2 equals 0. Then 3x plus 1 times x minus 2 is equal to 0. And then from here, 3x plus 1 is equal to 0, and x minus 2 is equal to 0. Then in the first equation, we have x equals -1/3, and in the second, x equals +2. Since we expressed tangent theta as x, we will now bring it back. So tangent theta is therefore equal to -1/3, and tangent theta is equal to +2. Now let's think. There is no +3 in either of special angle triangles. So this is not going to be a nice special angle, 60, 30, 90, 45, any one of those. So we need to use a calculator to determine tan inverse of -1/3. The only thing that we need to really think about is which quadrant tangent is negative in. When you do tan inverse of a negative ratio in a calculator, your calculator may only give you one answer. And normally you could have two, right? On the interval between 0 and 360. So it's always better to do tangent inverse of a positive ratio, determine the related acute angle, and then use the cast rule to find the angles where the ratio is negative. So if you try to determine the related acute angle given the positive ratio of 1/3, the related acute angle will be tan inverse of +1/3, and it will equal 18.4 degrees. Then use a cast rule to see where tangent is negative. The tangent ratio is negative in quadrant 2 and in quadrant 4. So the related acute angle is 18.4, and we translate it here. This is 18.4, and here, this is 18.4. But the principal angle will be this one, and then that one. So then, if this is 360, and this is 180, then for the first angle, we're not quite making it to 180, and we're not quite making it 18.4 degrees. Therefore, theta 1 is equal to 180 subtract 18.4, which is equal to 161.6 degrees. And the other angle, theta 2, we're not quite making it to 360, the same amount of degrees, 18.4, because that's our related acute angle. So the angle that we have here is 341.6 degrees. Those are the solutions to that first equation. Tangent theta is equal to -1/3. Now, let's move on to the other one. Tangent theta is equal to +2. This ratio is positive, and tangent is positive in quadrant 1 and in quadrant 3. So when we find the related acute angle, it will be one of the solutions for tangent theta equals 2. And the other angle will be 180 plus the related acute angle. Let's try. Tan inverse of 2 theta is equal to 63.4 degrees. And it is one of our solutions, so this is our theta 3. And theta 4 will be this whole angle all the way here to quadrant 3, where tangent theta is also positive. So 180 plus 63.4. So then theta 4 is equal to 243.4 degrees. This is our solution number 4, and this is our solution number 3. As you can see, for a quadratic type of equation involving trigonometry, we can potentially have 4 solutions on the interval between 0 and 360. You could have different situations. You could have no solutions for some if the ratio exceeds the range, or if you have an angle that falls right on the axis, like 0, 90, 180, 270. But in all other cases, you can expect to have 4 solutions. This is because every part of the equation will split into 2 linear parts, and each linear trig equation normally has 2 solutions on the interval between 0 and 360, because the ratio is either positive or negative in 2 possible quadrants. Here is another type of equation. This is a linear equation for now, but what we noticed here is that there are 2 different ratios involved. We have sine theta and we have cosecant theta. In some cases, in order to solve a trigonometric equation, you need to use trigonometric identities. There is a number of trigonometric identities that we can use in order to express one expression in terms of the other. They're called equivalent trigonometric ratios or equivalent trigonometric expressions. So in this case, we take 2 sine theta and keep it the way it is on this side, plus 1, and we can express cosecant theta as 1 over sine theta. Then, since we have now a denominator, we want to get rid of it, right? So we want to multiply every single part of our equation by that common denominator. And once we have a common denominator, we can drop it and only work with the numerator. So if we multiply every portion of our equation by the common denominator of sine theta, we're going to get the following: 2 sine theta times sine theta plus 1 times sine theta equals 1 over sine theta times sine theta. So what happens here is, in the first one, we're going to end up squaring sine. So sine squared theta plus sine theta, and in this case, sine and sine will reduce to 1. And then we have a quadratic equation of sine theta. So plus sine theta minus 1 is equal to 0. Now let's make sine theta. Let sine theta be x and solve this equation. 2x squared plus x minus 1 is equal to 0. If we factor this equation, we're going to get 2x minus 1 times 2x times just x plus 1 is equal to 0. So then from here, 2x minus 1 is 0 and x plus 1 is 0. Therefore, x is equal to positive 1 over 2. X is equal to negative 1. But we remember that x is equivalent to sine theta. So we're going to continue here. Sine theta is equal to 1 over 2. And sine theta is equal to negative 1. Let's go check out our cast rule right away. So this is a positive ratio of 1/2. Sine is positive in quadrant 1 and quadrant 2. And we have 1/2, which means we are dealing with a special triangle of 30, 60, 90. So 60, 30, 1, square root of 3 and 2. Sine is opposite over hypotenuse, and it corresponds to the 30-degree angle right here. And it's in the first quadrant, it's positive, so theta is equal to 30 is one of our solutions, so theta 1 is equal to 30. And the other one is this angle here, but the related acute angle is still 30 degrees. So we're not quite making it to a half of a rotation, which is 180. So theta 2 is equal to 180 subtract 30 degrees and is equal to 150 degrees. Now let's proceed to the other one. Sine theta is equal to negative 1. So when sine of the angle is equal to 1 or negative 1, it's one of the axis angles right here, this one or that one. So here, the 90-degree angle, its sine ratio is equal to positive 1. And the 270-degree angle, its sine ratio is equal to negative 1. So from here, theta 3 will equal 270 degrees. So this equation has 3 solutions. Even though it's a quadratic equation, one of the solutions falls right on the axis angle of 270, and there's only one possible solution to the sine ratio of negative 1, and it's 270. The other 2 angles are 30 and 150 on the interval between 0 and 360.